If possible, compute the following product. If not possible, explain why not. All right, to check if we can multiply matrices, and here we have 3 matrices, we should check dimensions. So it turns out all of these are 3 by 3 matrices. Now, how would we multiply 3 matrices together? Well, first you'd multiply 2 of them, and then you'd multiply the third with that result. You don't want to change the order here, and we're not going to, but you do have to be careful of that. I know sometimes people are in the habit of just switching things around because that's how multiplication works when it comes to numbers. But what have we got here? 3 by 3s, middle numbers match, and the end result, when I multiply these two together, will be another 3 by 3. So whatever that is, we'll take it and multiply it by this other matrix, which is also a 3 by 3. Okay, and oh, look, the dimensions match, and we'll get a 3 by 3 out at the end result of all of this. So yes, this is possible. We look at the dimensions to check that. And so now we're going to have to compute this. Okay, so 1, 2, negative 1. 1, negative 1, 3, 0, 0, 2. So here's our first matrix. 5, 1, 1. It was a 2 there, negative 2. 5, negative 1, 3. And the last matrix, 3, 0, negative 2, 1, 0, 1. There's a 4 somewhere in the last row. 4, negative 2, 2. There we go. So there's our 3. What did we say? We were going to multiply the first 2 together. It doesn't matter which pair, this pair or this pair. And people out there who are curious, I would challenge you. I'm going to do these 2 first. Try doing these 2 first. Okay? And then multiplying the other matrix out front. And you'll see you get the same answer. Okay? You do not get the same answer if you just start switching the places of these matrices. That's not how it works. But picking which pair to multiply together first will still work out. So what do we say when we multiply these two 3 by 3s? That it would equal a 3 by 3 matrix. So we'll do that, and then this one will just come along for the ride. Don't want to forget it. Okay? You'll notice it's at the end here. It stays at the end. It doesn't somehow come out front. Okay? You have to watch out for that. You can just very innocently think, oh, it doesn't matter. With matrices, the order matters. It absolutely matters. Okay, so we need to make this 3 by 3. What are we going to do? Well, first row dotted with first column. So 5 plus 2 minus 1, 6. And we'll just keep going now to the first row in the second column. So 1 and 1 is 1. Minus 4 is negative 3. Plus 1 is negative 2. Okay, now first row and the last column. We get 1 plus 10, that's 11, minus 3 is going to be 8. Okay. So now we'll take the second row, dot product with the first column. So 5 minus 1 is 4, plus 3, 7. 7 goes here. Second row dotted with second column will give us the 2, 2 entry here. 1 and 1 is 1. Negative 1 and negative 2 adds on another 2, so that's 3. And then minus 3, we're just going to get a 0 in the middle here. Okay. Second row and third column. 1 and 1, minus 5, plus 9. So 1 minus 5 is negative 4, plus 9 is 5. Okay. And the last row and columns should be easier because of all these zeros. 0, 0, 2 dotted with 5, 1, 1. Just going to be 2. 0, 0, 2 dot product with 1, negative 2, negative 1. Well, 2 times negative 1 is going to be negative 2. Looking ahead, we're going to get 3 times 2. We'll get 0 times 1 plus 0 times 5 plus 2 times 3 gives us 6. So 3 times 2 is 6 is our last result. And there we go. Now we've multiplied those first 2 matrices, but we have a third one to work with. And what did we say? It's 3 by 3 and a 3 by 3. The product should be another 3 by 3. So this will be our final answer here in a moment. And what do we have to do? Same thing we just did. Take one row from the first matrix, one column from the next matrix, dot product them together, and that gives you an entry in that row and that column for the result. Okay, so 6 and 3 is 18, minus 2 is 16, 8 and 4 is 32, so 16 and 32, 48. Okay. First row, second column. We'll just get minus 16 here. You need to go slower and write your dot products out while you're doing it? Of course you can. I mean, that's what scrap paper is for. Yeah. But you can, if you're comfortable, try and juggle it around in your head. Sometimes you make mistakes that way, and that happens. Okay. 6, negative 2, negative 12, minus another 2 is negative 14. 8 and 2 is 16. 16 minus 14 is 2. Okay. So now we'll take the second row and the first column. 3 and 7 is 21, plus 9. Oh, not 9, I almost added them. See how you can make mistakes? 5 and 4 is 20, so 21 plus 20, 41. So there's second row. Now we'll do second row, second column. 0 and 7 is 0, 0 and 0 is 0. 5 and negative 2, we're going to get negative 10 here. Negative 14 plus 10, negative 4 for the last entry in this row. Third row, first column, you multiply or you dot product them together. 2 and 3 is 6, minus 2 is 4, plus 24 gives us 28 here. Third row, second column, we're going to get minus 12 here. And finally, third row, third column will give us the 3, 3 entry, the last entry we need. 2 and negative 2 is negative 4, minus another 2 is negative 6, plus 12 is positive 6. And there's our final answer there.